Anyways, it's an absolute pleasure, Chris. It's great to be here to celebrate your accomplishments throughout your career. And I'm going to talk briefly about the thread of the stage that Chris set up before I got to GFDL as a postdoc in 2015, and how that led to building blocks for a lot of the tiling that we're doing at GFDL. And so I want to do this by talking first about this idea of hill slope heterogeneity. So this is a paper by Ying-Fan. It came out in 2019. And this is a concept that we've been thinking about a lot in hydrology over global scales for a while. And if you look at this on the right and the left, you see this rolled aspect, so north versus south, and how that actually impacts not only water, surface energy partitioning, but it also is going to impact ecology, biodiversity. And you also have topographic convergence. So the classic idea in hydrology and like the top model type approach is this idea of the role that topographic convergence plays in, for example, riparian zones. So these are all processes that we know matter. And I guess it's gonna be a little hard to add some animation, so this is gonna be a little difficult now. Kirsten, if I show now, is it still small?
Yeah, that didn't change. I'm sorry, we're not seeing the animation.
But the main story is, so with hill slopes and versus the models, this is a subgrid for quarter degree in the southern Sierra Nevadas. So you're able to see and pull this out from Landsat. We're able to see the clear depiction of a north-facing slope versus a south-facing slope, and how that plays out in terms of surface temperature. And if you look really close in detail, you actually see the riparian zones start to pop out. So why should we care? Well, think about the surface energy partitioning, how that matters when you think about where you're facing. Think about runoff generation. That's the classic way that we think about hill slopes. And you can also think about biodiversity, among others. So I'll bring this back up here. So effectively, hill slope heterogeneity, both intra and inter, has been on the to-do list in ESMs for decades. This is not a new thing. The work that Chris did, let me just go up here, for LM3, he really set the stage to be able to make really big push to be able to accomplish new things. And basically a lot of ESMs, if they had any sort of hill slope hydrology, the representations are primarily through a classic top model approach, which is mainly primarily for humid and climates and moderately steep slopes. So this lumped characteristic idea, which the focus on runoff generation, they brought into LM3, you can think about it as a generalization of top model for broader use, for broader climates, for example, semi-arid, and hill slope properties, so gentle slopes. And that really helps spark the ongoing shift towards more robust hill slope hydrology in ESMs. And in setting the stage for a lot of the work that I was able to contribute at GFDL, it put in place a model infrastructure to represent subgrid diversity of hill slopes. And when I say diversity of hill slopes, I mean accounting for that north versus south, convergent versus divergent. So parallel to that, towards the end of my PhD, I was working on these ideas, which the hydroblocks comes out of this, where think about heterogeneity, you can think about a clustering problem. So you have all this data for these regions. This is the site in the southern Sierra Nevadas, and the naive approach was doing this. So let's just take this as a clustering problem. So throw everything at a clustering mechanism and out come the tiles, and you have your distribution of tiles for your grid cell. And you can use that then as your tiles that go in. The problem with that is that it ignored a lot of the geomorphological structures that we tend to think about matter a lot in hydrology, for example, hill slopes. And although it did interesting things in terms of surface energy partitioning, just simply brute force clustering was not going to be a solution when we think about runoff generation. And so bringing the ideas of LM3 characteristic hill slopes together with this idea of clustering was really the underlying premise behind this idea of hydroblocks meets these LM3 hill slopes. And so this is from the 2018 paper with Chris and Elena and Sergey and others. And effectively, the idea is you take this elevation data, you do some terrain analysis, you come up with your hill slopes. So we're actually getting those geomorphological units. And then we're actually going to learn average properties for each of those hill slopes. And then we're going to bring along the environmental data. And with that environmental data, then we're going to learn these properties, which are then going to apply a clustering mechanisms, and out comes your characteristic hill slopes. So it's a very simple way to come up with this north versus south, convergent versus divergent hill slopes. So we get all of the efficiency that you're going to get from reducing that space from 1 million pixels down to 6 characteristic hill slopes, while getting the process representation that we want. Then an extension of that was LM3 TiHi with Chris collaborated heavily with Zach Subin. We're effectively this idea of splitting them into these what we call height bands, so discretization. So it allows us to take this idea of a hill slope and move beyond just simply runoff generation and think about how it impacts surface energy partitioning, think about how it impacts the carbon cycle, etc. And the way that I do this, or I think about it, is this characteristic hill slope idea. So you're splitting into these height bands. And in those height bands, you have these different interband tiles, which account for land cover and soil heterogeneity. And then you have these topographic gradients that connect the height bands. And you can think about tile connectivity happening between those. And all that had its foundation in both the LM3 and then the LM3 TiHi efforts. And so where this has gone, think about it as what we call LM4 hydroblocks, where effectively think about a grid cell as a macro scale polygon, although you don't need to stay in the bounds of a regular grid. Think about taking this data and clustering the geomorphological units. You can think about a hill slopes. You could also do watersheds, but make sure that you have those geomorphological units. Then take that discretization and think about the height bands, and then think about happening inside that to account for urban areas, to account for soil heterogeneity, land cover heterogeneity. And that leads to these maps of tiles, which you can then use to be able to include that in the model in an effective and efficient way. And I had this of what this allows us to do now. And this is there's going to be an animation that's going to pop up. Let's see if I can just scroll through this the old classic way. This is what I get for trying animations. So the one is mapping subgrid to field scales. So we have these cluster maps. We're able to produce field scale estimates, and here you can see the clear representation of riparian zones that you're getting from including these idea of these discretized hill slopes. So another one is the ability to this two-way subgrid coupling. So with these characteristic hill slopes, you bring together a subgrid river routing scheme, and that allows you to then represent processes not just from a hill slope, but riparian zone, but also redistribution via vector river networks. You can think about downscaling, and Elena brought this up with regards to precip, but effectively being able to take this aspect information that we're getting in these characteristic hill slopes and really bring your mean shortwave radiation and bring it down to the hill slope scale. And other efforts involve actually getting at trying to evaluate, is the subgrid space-time patterns that we have, are they actually realistic? And is all this heterogeneity that we're including, is it actually what we should be doing? And the last one, and this is a lot of effort by Noemi, is really the ability to data assimilation at field scale. So you're able to bring all of this heterogeneity information and bring it together with remote sensing data such as SMAP. So that is the last of my slide. I want to take a brief moment, and Chris, to talk about the role that you've played. You might not have realized it, but you definitely played a big role in my career. And as we were, I was like an hour into the presentation, right before Kenny Yang gave his presentation, I was going through and listing right here, what are some main things that came to mind? And then when Kenny gave his, I was like, well, that's almost exactly what I was going to say. So some of the things that I've learned from you, Chris, and I will always be appreciative, is to not rush science. Don't move away from the shotgun approach to science and actually go and be precise and try to accomplish a goal and do it well. I learned from you to not oversell, to actually be proud of the science that you're behind and let that science speak for itself. Be careful and meticulous, and also be very self-critical. So in that sense, make sure that I'm aware of the deficiencies of my research and make sure I and try to improve them. When I was giving my job talk at Duke in 2018, I remember one of my antepenultimate slides was I'd done all of this talking about heterogeneity, and then I spent a slide talking about how a lot of it doesn't work. And it's that self-criticism in many ways that showed that how I was able to be self-critical and want to improve what I'm doing. And so I'm very thankful to you for that mentorship that you gave. And best of luck in your retirement. It's been a pleasure to work with you throughout the years. Thank you.
Thanks, Nate. Yeah, I really appreciate that. The kind comments at the end, especially. Yeah, the hill slope hydrology, you know, when Zach Subin and I put that together, you know, that was hard enough, and we realized there was a lot of potential to use that as a kernel with which to really deal with all these issues that you're dealing with. And I'm just delighted that you have been able to pick that up and run with it and really realize it even further than, you know, my vision had seen it go. So thank you for that.
Thank you. Without your the seeds that you put in there, it probably never would have happened. But the combining of the two concepts, I think it's led to something really interesting. So thank you.